Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Beyond the Border by Duarte Carvalho. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that every row, column, and designated 9-cell region contains the digits 1 through 9 once each. We have X sums, where numbers outside the grid give the sum of the first X digits along that row or column, where X is the first digit seen from the direction of the clue. So, for example, if this were, say, a 5, the first 5 digits in this direction must add up to 23, because that's the clue outside the grid. If we could also say have a 4 here, then the first 4 digits in this row going this way would also have to add to 23, because the X digit here signifies how many digits you sum up to add to the sum that's outside of the grid. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, first thing that I see is we have no sums here which are 1 or 45. If you have one digit as the digit, that's the first digit, it has to add up to 1. If you have 9 as the first digit, that means you must have the sum of all 9 cells in the row or column, which adds up to 45. Since we have 7 clues here, here, and here, none of which add up to 1 or 45, the remaining digits which don't have clues must be the 1 or the 9. So this is 1 or 9, this is 1 or 9, this is 1 or 9, 1 or 9 here, 1 or 9 here, 1 or 9 here. So those are guaranteed. Here in row 4, these digits must sum to 5. And we cannot have a 1 here because that only adds up to 1. So this has to be 2. And then this is 3. Because you can't have 3 unique digits ever sum up to 5 in normal Sudoku rules. So this is 2 and 3. What else do we have? The digits here have to be at least 8. It could be, sorry, it has to be at most 8, and it could be 7 to add up to 39, right? Which of these can have 2 as the first digit? Okay, again, we have a 5 here, so this must be 2 and 3. So this is also 2 and 3. Therefore, these 2 digits must add up to 7, so this is 2 and 5. These 3 digits add up to 18. These 5 digits add up to 23. So how many digits here can add up to 8? It cannot be 2 because of 2 in the column. Obviously can't be 1 again, so this has to be 3 digits because 4 digits at minimum add up to 10. 1, 2, 3, and 4. So this must be 3. That means this can never be 9 because 3 and 9 already add up to 12. So this is 1, this is 9. That makes this a 9 and this a 1 here. So this must be 3, 1, and 4 adding up to 8. And we had 3 in the corner, so we celebrate it because we're starting to get close to solving it. Which of these digits can have a 2 with it? None of these, because this 2 and 35 adds up to 37, etc., etc. So this has to be 2 here and 5 here. Okay, remaining digits in column 1. We have 4, 6, 7, 8. This can never have 6 digits adding up to 617, because 6 digits at minimum adds up to 21, right? 1 plus 2 plus 3 plus 4 plus 5 plus 6. So this has to be a 4 here. 24 similarly cannot be 7 or 8, because the minimum of 7 unique digits adds up to 28. So this is 6. This is similarly 32 cannot add up to 8 unique digits, because the minimum of 8 unique digits adding up is 36. So this is 7 and this is 8. We can keep doing that with these digits here. 20. We have 4. Actually, so this one's not as useful. Remaining digits are 5, 6, 7, 8 in row 9. This can't be 5 because of 5 in the box. This can't be 5 because 5 unique digits cannot ever add up to 40. So one of these two is a 5. That's fine. This digit cannot be 7 or 8, because if it is, the remaining digits here must add up to 38 at minimum. Or sorry, at maximum. And therefore this can never be a valid x sum. So this has to be 6 or 7, 5 or 6 here. Can this ever be 6 digits adding up to 40? The answer to that would be no. Because 6 digits adding up to 40 would only add up to 39 at maximum, right? 9, 8, 7, 6, 5, and 4 adds up to 39. So this can't be 6, this is 7 or 8. Remaining digits in row 1 then are 4 through 8. This cannot be 5. You cannot have 6 unique digits ever add up to 20 in normal Sudoku, because the minimum is 21. So this has to be a 4. So this is 4. This can't be 4. This can't be 4. This can't be 4. This can't be 4. What digits add up to? What digits can 8 digits add up? What sum, sorry, can 8 digits add up to? It cannot be 31, 32, or 34, because the minimum for 8 digits is 36. So this has to be an 8 then. So this is 8, which eliminates 8 in the rest of the row. And this must be 8 digits adding up to 39, which forces this to be a 6. So this is then 5. This cannot be 6 here because of the 6 in the row. The first 6 digits here must add up to 27, which means the last 3 have to add up to 45 minus 27, which is 18. We already have an 8 here, so this cannot be a 1-9 pair, because that would eliminate all possibilities for the cell. Cannot be 2-7, cannot be 4-6, or 2-8, sorry. Can't be 4-6, so this has to be a 3-7 pair here. That eliminates 3 and 7 in the rest of the box and column. Remaining digits here then are 1, 4, 5, and 9. 5 cannot be here because of the 5 in the box. This can't be 9 because of 9 in the row. So does the first 6 digits add to 27? 1 and 9 add up to 10. Plus 4 and 5 adds up to 19. Plus 2 is 21. Plus 6 is 27. This can't be 1 because of the 1. One digit only adds up to 1. Cannot be 9. So this is 4 or 5. Okay. Can this ever be 8? If this were 8, the first 8 digits would have to add up to 37, and then the last digit would have to be 8. So this cannot be 8. This has to be 7. This is 8. This 8 means the first 8 digits add up to 40, so the last digit must be 45 minus 40, which is 5. So this is 5. This can't be 5 or 7, so this must be 6, which makes this a 7. Here we have the first 5 digits adding up to 31. This is the first 8 digits here adding up to 40, so this can't be 4. This is 45 minus 40, which is 5. So this cannot be 5 here. Remaining digits in this upper right-hand box are 1, 2, no 3, 4, 6, and 9. Okay. The first 5 digits here must add up to 31 without an 8. So that means what's the maximum for 5 digits now? We have 9, 7, 6, 5, and 4. What is that sum? 9, 7. So you have 7 and 4, which adds up to 11 times 2 is 22. Plus 9 is 31. So the maximum value equals the sum. So it must, if you try to minimize any other number or subtract any number, that means it won't work. So this has to be 4, 6, 7, 8, 9. These could be 6. That leaves the remaining digits in column 7 as 1, 2, and 3. This cannot be 2 or 3 because of the 2, 3 in the box. So this is 1. That forces this to be a 2, 3 pair here. Okay. This has, okay, let's do, this is 3 digits adding up to 18. So it's either 3 and 6, 9 or 7, 8 here. Okay. This 6 eliminates 6 here. This 1 eliminates 1 in the box. So a guaranteed one of these is a 7 because it cannot be 7 here. This is 2 and 5. Okay, so this is 7 digits adding up to 34. So these 7 add up to 34. Sorry, 37. Right, 37. So these add up to 37. Therefore, these two must add up to 45 minus 37, which is 8. So this is 6. Therefore, this is a 2. This adds up. These 7 add up to 32, which means these two add up to 45 minus 32, which is 13. So this must be 4 and 9. So this 4 eliminates 4 here, so that's 1, which means this can't be 1. First 4 digits. Okay, so this is done, this is done, this is not done, neither is this, neither is this. This is essentially done. 7. So the first 7 digits here again add up to 32, which means these 2 digits must add up to 45 minus 32, which is 13. And we have a 4 and 9 here, which induces this to be a 4 or 9 here, because there's no other possibility, right, to add up to 13 with 4 or 9. It's just 4 or 9. Therefore, we have a 4, 9, 4, 9 pair, which eliminates 4 and 9 in the rest of the box. So this is 7. Interesting. The first 5 digits here must add up to 35. The maximum for 5 digits is 35. So it's 5, 6, 7, 8, 9. So this cannot be 4. This is 9. That's 4, which makes this 9. This has to be in 6 and 8. Because we need 5, 6, 7, 8, 9 for 5 digits to ever add up to 35. So this cannot be 9, and it cannot be 6 or 9 here. This becomes a 4, 7 pair here. This cannot be 6 or 9, so this is a 1, which forces this to be 9. And this can't be 1, 6, or 9 now. It's a 2, 4 pair, which eliminates 2 and 4 in the rest of the box. This 2 eliminates 2 here, so this is 4 and 2. This can no longer be 3, 6, 9 adding up to 18, so it's 3, 7, 8. So okay, this 8 eliminates 8 here, so it's 6 and 8. The first 6 digits here add up to 24, so the last 3 must add up to 45 minus 24, which is 21. So this has to be 4, that's 7. The first 5 digits, or no, the first 2 digits here add up to 5. Okay, that's fine. That's done. This is done, essentially. So 2, 3 add up to 5. 2, 5 add up to 7. Okay, the first 5 digits here add up to 23. That means that the last 4 must add up to what? 22? Right, 45 minus 23 is 22. 22 minus 6 is 16. Only 2 unique digits can ever add up to 16. In normal Sudoku, it has to be 7 and 9, which makes this 6 and 3. This 7 eliminates 7 here, so it's 8 and 7. Remaining digits in this upper left-hand box are 1 and 6. This can't be 6 because of the 6 in the row. So this is 1, that's 6. First 4 digits here add up to 17. We have 4, 7, 1 adding up to 12, so this is 5. That leaves 8 and 9 remaining in row 3. It leaves 1 and 3 remaining in row 2. Okay, so this is done. This is 2, 3 is done. 2, 5 is done. 5 is done here. 5, 8, 6 adds up to 19 plus 1 and 3 is 4, adding up to 23. 4, 7, 1, 5 is done. 6 is basically done because 4, 8, 9 adds up to 21. So the first 6 then add up to 24. 8 is done. 7's done. 3, 4, and 4 is done. 3, 9, 7 here. I didn't even check this, but that adds up to 19. First 4 here adds up to 17. So let's go from column 1, or row 1. So 3, 8, 7 works. 7 works because 4 and 9 add up to 13, and those are the only 2 left out. These must add up to 20. That's not quite done. Remaining digits in this lower central box are 1, 3, 6, and 8. 1 cannot be here, 6 cannot be either of these. So 6 is guaranteed to be one of these two. The remaining digits in this lower left-hand box are 2, 5, 6, and 8. 6 cannot be either of these. It cannot be here. Where is the 6 in this box then? It has to be here. This can't be 5 because of 5 in the row. This can't be 8 because of 8 in the column. This must add up to 17 with 4 digits. That means the remaining digits add up to 28. Is that right? 45 minus 17 is 28, yes. So these add up to 28. We already have 169, which is 16. So 28 minus 16 is 12. So these must be 2 digits adding up to 12. We cannot have 3, 9, so it's either 4, 8 or 5, 7 here. And this cannot be 4, 8 because of the 4, 8 in the row. And actually, there's a 4 here, so this can't be 4, 8. This is 5 and 7. This 7 eliminates 7 here, so this is 5. That's 7. So this cannot be 5. This becomes a 2, 8 pair. So we have 2, 8, 4, and 3 adding up to 17, which is correct. This can't be 2 anymore because of the 2, 8 pair, so this is 5. That means the remaining digits in column 2 are 2, 4, and 9. This can't be 2, this can't be 4 or 9, so this is 2, which means this can't be 2 here. Remaining digits in row 5 are 1, 3, and 5. This can't be 5 because of 5 in the column. This can't be 5 because of 5 in the column. So this has to be 5 here. We have a 1, 3, 1, 3 pair in column 4, which eliminates 1 and 3 in the rest of the column. So this can't be 1 or 3. We have a 1, 3, 1, 3 pair in column 5, which eliminates 1 and 3 in the rest of that column. So this can't be 1 or 3. We now have a 6, 8, 6, 8 pair in row 7, which eliminates 6 and 8 in the rest of the row. This can't be 8. This is 2. This is 8. 2 eliminates 2 here, so it's 3 and 2. This 8 can't be 8 here. This can't be 3, so this is 1. This 8 eliminates 8 here, so it's 3. We have 8 2s. We know where the last 2 has to be. It has to be here. 1s we have, they're kind of, Okay, first 6 digits here must add up to 34. So 32 is basically done. This remaining digit is 6 or 8. So this is done both ways. We'll make pink on the in the rows. This is done. This is essentially done, right? We have 4 and 9 here. This is not done. 6 is done because the first 6 digits the last 3 digits add up to 11, which 45 minus 11 is 34. So therefore this is 34. First 5 digits here are done. That adds up to 31. We have 14 plus 13 is 27 plus 4 is 31. This is done in the column because 45 minus 6 is 39. This is done. 2 and 3. 5 digits. Okay, so this is not yet done. That means the last 4 digits must add up to 22. So we have 12 and then, so 22 minus 10 is 12. So this is 3 and 9. So this is 3 and 9, which makes this 4. So this is now done. 6 digits adding up to 27. This adds up to 12 or 13. 45 minus, no, it's 18. 45 minus 18 is 27. So this is done. 5 digits adding up to 35. 5 through 9. 8 digits adding up to 40 with a 5 outside. 7 digits adding up to 37 would make 8 outside of the x sum. So this is done. 2 and 5 add up to 7. 4, 2, 8, and 3 add up to 17. And this works both ways. Also, we've done all these. So we satisfied this, and these two. So we just have that one now. Okay. 4 digits adding up to 20. Can you ever have a 1 here? Yes, I guess you could. Remaining digits in row 4 are 6, 8, and 9. Okay, so that's good to know. 6 cannot be here because of the 6 in the column. We have an 8, 9 pair here, which eliminates 8 and 9 in the rest of the column. So that leaves this as a 4, which makes this a 7. Okay. So for this 4, you have to have 1, 1, or 3 there. If it's 4 and 1, this must be 6 and 9. If it's 4 and 3, that adds up to 7. 20 minus 7 is 13, but none of these combinations add up to 13. You have a minimum of 6 and 8 here. So this must be 4, 1, which makes this 3, which makes that 1, which makes that 3. And this has to be 6 and 9, adding up to 20. Which makes that not 9, so it's 8, which makes that 9. This 6 eliminates 6 here, so it's 8, 6, and 8. And that's a solution. I don't know. Maybe it's because of how much addition. I mean, none of the logic here. All the logic here I would consider very easy. But there's a lot of math you have to know. I don't know. Would I consider it very easy? Maybe a touch harder than very easy. Maybe somewhere slightly harder than very easy. Interesting. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.